In this video, we'll be looking at confidence intervals for proportions. In a previous video, we learned about the central limit theorem for proportions. We learned that proportions are normally distributed if we survey multiple samples and certain conditions are met. For the results of these surveys, the average proportions of all the samples, P, is in the center of our normal curve, and the standard deviation of our proportions can be calculated using a formula that we will be revisiting in this lesson. In the example that we previously explored, several samples were surveyed to see what proportion of each sample were pet owners. We learned that the proportions for all our samples, if graphed on a histogram, would form a normal curve with the average proportion at the center. This average proportion, if sufficient samples are taken, also represents the true proportion of pet owners in our population. The problem, however, is that surveying multiple large samples is not often a realistic goal. How then can we get the true proportion? If we don't survey multiple samples, we can't get an average proportion that represents the true proportion. But that's okay. We can survey just one sample and get useful information from our sample proportion. Instead of putting the average proportion at the center of our normal curve, we place our sample proportion, indicated by p hat, in that position. Previously, the standard deviation helped us to see the spread of our data from the mean, but since the mean is not at the center of this curve, we will be using a number called the standard error instead. Okay, let's jump in and see how this all works together. Here's our normal curve. When we survey a sample, our proportion is placed here, at the center of the normal curve. We will be using standard error in place of standard deviation, since the average proportion is not in the center. The symbol for standard error is an uppercase E. We don't have to survey several samples. We can be confident that 68% of our proportions are between one standard error below and one standard error above our sample proportion. 95% of proportions are between two standard errors below and two standard errors above our sample proportion. And 99.7% of proportions are between three standard errors below and three standard errors above our sample proportion. To find the standard error, we use the formula E is equal to the square root of P times 1 minus P over N, or sample size. It is important to note that in this case, this is P hat, representing our proportion, not the average proportion. Let's take a look at what this could look like in an actual example. 35% of people in a randomly selected sample of 200 are pet owners. Give the 95% confidence interval and explain what that means. We know from our normal model that 95% of proportions are between two standard errors below our sample proportion and two standard errors above our sample proportion. Our sample proportion is 35%, or 0.35. To find the standard error, we use the formula E is equal to the square root of 0.35 times 1 minus 0.35 over the sample size, 200. Our standard error is 0.0337. Multiply this value by 2 to get two standard errors. We get 0.0674. Our 95% confidence interval is our proportion, 0.35, plus or minus two standard errors, 0.0674. Let's see this on our curve. Our proportion, 0.35, is in the center. We add one standard error to get 0.3837, then a second standard error to get 0.4174. We take away one standard error to get 0.3163, then a second standard error to get 0.2826. Our confidence interval can also be given as 0.2826 is less than P, which is less than 0.4174. We know from the normal model that 95% of proportions are in the range from 0.2826 to 0.4174. This means that we can say with 95% confidence that the true proportion is in this range. Here's a summary of what we've learned. A confidence interval is a statement telling us the level of confidence that a true proportion is in a specific range. Confidence intervals are different from central limit theorem because we don't have the average proportion. Required conditions are the same as those used for the central limit theorem of proportions. Your sample proportion is used for the center of the normal model. The standard error is used instead of the standard deviation.